So hello everyone, let's just continue with the next topic of ours, and it is known as Remainder's theorem. It is very important in polynomials. Let's just have a look over it. So Remainder's theorem. Now what the Remainder's theorem states? So Remainder theorem states that when a polynomial p of x is divided by a linear polynomial x minus a, then its we can say its remainder will be p of a. Okay, it will be always equals to p of a. So you can see here, like you know what, with the help of this we can easily find the remainder. Okay, like we have seen how to divide the polynomials, and we cannot say it is very easy, right? It's a bit lengthy, right? So with the help of that particular thing, with the help of remainder theorems, it becomes easy for us to find the remainder. Okay, so here you can see the same thing is given to us, that if you want to find the polynomial, if you want to find a zero of the polynomial, so just do one thing. If you want to find the we can say the remainder of a polynomial, then just do one thing, settle it to 0. Okay, just settle it to 0, and like x minus a is equals to 0, then you will get x equals to a. You are having the value, just substitute it to the polynomial, then you will get the remainder of yours, right? Now let's just understand the proof of it. Okay, how it is working. So for example, let's say you are having a polynomial, and we will just divide it with a linear polynomial, and then we will check whether we are getting the same thing or not, right? So here for the proof, the most important thing we are having is that division algorithm, right? You all are familiar with the division algorithm, right? So this is very important. You can see here, so division algorithm states that dividend equals to the divisor times quotient plus the remainder, right? We all know that, right? Now in the same, let's put all the things. So let's say using this, we have just constructed it, right? That p of x, it is our dividend, and x minus a is our divisor. Let's say q of x, we got a q of x as the quotient, and r is our remainder. If we are having these things, okay, if we are having these things, so we have just arranged them according to the division algorithm. Now just substitute the value. If I'm substituting the value of x equals to a, then that whole thing will become like p of a equals to a minus a times q of a plus r. So this expression will become 0, right? This thing, like these terms, x minus a, sorry, a minus a will become 0. So a minus a times q of a will also be 0. So you are getting p of a equals to r. So this is the proof of Reminder's theorem, right? Now let's just move ahead and see another thing. So here, how we can find the polynomial, right? How we can find the remainder using the polynomials, and we are just dividing them. How we can find the remainder? It is the question we are having. So you can see here how we can do it. Let's say we are having one example, x cube minus 3x square plus 4 of x plus 10, and we are dividing this with x plus 1. Okay, let's say we are given with this, and we have to find the what? We have to find the remainder. Then what will you do? You will just follow the things, right? You will just divide the whole equation. Like first we are having x square, because when we divide x cube with x, we will get x square. So we are having that x square. Now we have just multiplied the x square with the x plus 1. So we got x cube plus x square, right? Now we will subtract it. So we have changed the sign. Positive becomes negative, right? Now x cube and x cube will get cancelled, and negative 3x square and negative x square will give you negative 4x square. We are having that. We will take plus 4 of x and plus 10 from the above, and we will write it here. Now you can see here, we will do the same thing, right? The same thing as we have done previously. We will divide that 4x square with x. When we do this, we got negative 4x as our quotient. So we have written it at the place of quotient. Now multiply this x plus 1 with negative 4 of x. When you do this, you will get the terms as negative 4x square, negative 4 of x. Just do the same thing again, change the sign, negative becomes positive, negative becomes positive. When we do this, so this negative 4x square will be cancelled by positive 4x square. Now Positive 4x and positive 4x will give you positive 8 of x, and this 10 will comes down. Okay, so we take it down. So 8 of x plus 10. Now we will do the same thing. We will divide that 8 of x with x. So we got 8, multiply the 8 with the whole term. So we got 8x plus 8. So when we do the same thing, when we subtract it, we got our remainder as 2, right? So you can see how long the process is, right? Then we are getting the remainder, but with the help of remainder theorems, it becomes easy, right? For example, just take this one. We are having this example here. It says using the remainder theorem, we have to find the remainder when x to the power 6 negative x to 5 to the power x to the 5x to the power 4 plus 3x to the power 2 plus 10 is divided by x minus 2. Right, now just go according to the remainder theorem. What remainder theorem says? It says that if I'm dividing it with this x minus 2 and if I'm taking p of a, then the remainder will be equals to p of a, right? So I'm just using it. So I'm having p of x as x to the power 6 negative 5x to the power 4 positive 3x square positive 10, right? We are having this. Now I'm taking the value of x as, if we are having x minus 2, then xc will be equals to 2 now. So that's why I'm taking p of 2. So it will be like 2 to the power 6 negative 5 times 2 to the power 4 plus 3 times 2 to the power 2 plus 10. Okay, in that way. Now just solve this. So let me write it clearly. Okay, now let's just solve this. Okay, this is 5. Okay, so when we solve this, so 2 to the power 6 is equals to what? 2 to the power 2 is 4, then 4 2s are 8, 8 2s are 16, 16 2s are 32, 32s are 64, so it is equals to 64. So 64 negative 5 times 2 to the power 4, so 8 2s are 16, so it is 16 plus 3 times 4 plus 10. Okay, now just subtract it. Okay, but first simplify it. So 64 minus 16 5s are 80 plus 12 plus 10. Now just solve it further. So 64, you are having this 12 plus 10. So 12 plus 10 will be 22. 22 plus 64 you have to do. So 86 you will get. 86 minus 80. So it will be equals to 6. Now you can see how smoothly and how fast we have calculated the remainder. Okay. So if you are having x as 2 and if you are dividing the expression with x minus 2, you will get remainder as 6. Okay, so this is how we can find the remainder using remainder theorem. Now we are moving ahead, and now we are having another thing which is known as factor theorem. So similarly, like the remainder theorem, factor theorem is also very important. You can see here it states that as per the theorem, x minus a can be considered as a factor of the polynomial f of x of degree where the degree of that polynomial is greater or equals to 1 if and only if f of a is equals to 0. Okay, and here a can be any real number. Okay, just understand this thing. Okay, it can only be the factor if f of a is equals to 0, right? So you can see here also, right, this whole thing, it is also the same thing, right? So factor theorem, what it says, when fc is equals to 0, then x minus c is a factor of x, and when x minus c is a factor of x, then fc is equals to 0. So it is nothing but just the converse of factors theorem, right? It is very important theorem. And just understand one more thing, the factor of x minus c and the root of c are the same. Okay, the roots and the factors will be same, always remember. Now we are having some important points related to the factor theorem. So you can see here, right, the very first point, it is if x plus a is a factor of a polynomial p of x, if p negative a is equals to 0. Okay, so you can see x plus a is a factor of polynomial p of x if p of a minus a is equals to 0, right? Then the second point says a of x minus b is a factor of polynomial. So it is same. You just need to put the value as b by a, right? And if it is equals to 0, so here if you are having the positive sign, so it will become positive. So p of a, like p of minus b by a equals to 0, right? We are doing nothing but just changing the signs, right? You can see here, right? We are just substituting it. Now the next thing, so it is given that x minus a and x minus b is a factor of polynomial p of x if p of a is equals to 0 and p of b is also equals to 0. Okay, then only these two will be the factors. Okay, so these are some important things. Now on the basis of same, we are having one thing, right? We are having one question of ours. It says that use the factor theorem to check whether y plus 1 is a factor of the polynomial 3y to the power 4 plus y cube minus y square plus 3y plus 2 or not. We have to check. How we will check? How we will check? We have just seen the converse of factor theorem now. So it states that if we can say if p of a is equals to 0, then x minus a is what? It is a factor of p of x. So let's just have a look here. Now what we will do, we will just subtract the we will just substitute the value. So we are having y plus 1, right? So it will like we will substitute the value as y equals to -1. If we are getting y equals to -1 as 0, then it is a factor of that. Okay, it is the factor of that expression. Now just put the value. So it will be like 3 times -1 to the power 4 plus 3 to the power 3 minus sorry, it's not 3, actually it will be -1 to the power 3. Okay, -1 to the power 3, then -1 to the power 2 plus 3 times -1 plus 2. Now just simplify it. So it will be like -1 to the power 4. It will be a positive number. So 3 times +1 will be 3 only. Then here it is negative. You can see it is the negative sign and the power is cube. It means you will get a -1 only. Here a positive 1, but positive -1 only. Here 3 times negative, so -3 and plus 2, so plus 2. Okay, so from this negative got cancelled. So -2 +2 is equals to 0. We got the 0. It means y plus 1 is a factor. Okay, it means it is a factor of that expression. So in that way you can understand it and you can find the factors.